Hello and welcome. My name is Dominika from RoboCamp and we're about to begin the Carousel robotics lesson. The lesson includes building, programming, and experimenting with the robot. To complete it, you need Lego Spike Prime and wooden parts cut out with the help of X-Tool laser cutter. Templates and instructions are all provided. Throughout the lesson, I'll be using step-by-step instructions with graphics, videos, and explanations, which you'll see somewhere here on my right. Remember that you can use them too, either to narrate the lesson yourself or perhaps to share the instructions directly with your students. Now let's begin with a quick introduction. Carousels, as some of you surely know, are one of the most popular rides in amusement parks. The one you see on the picture here is a subtype known as a swing ride. Now look at the seats. They are attached to chains suspended from a fast spinning disc at the top. Now when the carousel rotates, the seats, together with the passengers, tilt away from the center. This phenomenon causes interesting effects for passengers because of the forces that they experience firsthand. We are going to build a similar model with wooden airplanes mounted on swinging arms. According to physics, any object subjected to a sufficiently large force will move in a straight line. However, the design of a carousel makes it impossible for the seats, or airplanes in this case, to move in a straight line. Instead, the centripetal force generated by the rotational motion keeps them moving on a curve. By the way, the sensation of being pushed outward, this desire to escape the curved path, is the result of the centrifugal force. It is an apparent force, but it feels very real when you're on a swing ride. So, let's build it with bricks and wood. You will need one Lego Spike Prime set and wooden parts cut with the help of the X-Tool laser cutter. I'll start with the latter. The templates are ready and waiting in the download section for this lesson. Download them and open the file. It should open in the X-Tool Creative space. Now to save us some time, I already have downloaded it and have it open right here. Okay. Let's continue. And here we are. Here's all the parts that you will need. Okay, so in this project, we're using a plywood sheet that's 3 millimeters thick. The cutting power and speed setting are already defined. Adjust them only if you're using another type of material. Now, when you're happy with this, when you're happy with positioning, select Process. The preview shows how long the cutting process will take and how the laser will move. The Start button in the top right corner sends the file to the machine. But before you click it, don't forget to place a wooden board inside the X-Tool. Then, start the cutting process and wait. Be sure to check on the process every now and then and do not leave this device unattended when it's working. wooden parts are ready, but we still need to assemble the base for the carousel. So prepare your spike prime set and follow the instructions. This is my workspace. As you can see, I have bricks in sorting trays. They are all sorted out. I recommend you do the same. It makes everything much faster and easier. Right here, I have my wooden elements, okay? And now let's take a look at the instructions. Okay, each step, as you can see here, shows you the elements that you need. There's also the before and after to make everything clear. Now, first let's find the base plate and 2 half pins as the instruction shows. And as I already mentioned, if your parts are sorted, this should be easy. Also, I will try to switch my view every now and then so that you can see how this construction looks like in real life. Okay, so let's do this right now. Okay, first plate and 2 half pins. Note that my building pace certainly not the fastest, but I am an adult, so it is faster if you're teaching. If you're teaching kids, their pace might be slightly slower, so be sure to take it into consideration. Okay, now we need 2 yellow connectors. Next, again 2 half pins. 1 and 2. Okay, now we need our first sensor. Take a look how it's installed right here. And I'm going to switch the view. Take the sensor right here. This is the distance sensor, okay? And we need to install like so. By using those half pins I have installed earlier. Okay? Here's how it looks like. Notice how the cable looks like in the after image here, right? Before and after. Almost as if it's slightly hidden. I will try to achieve a similar effect on my construction and perhaps adjust it later on, okay, to see how it works like. Okay, next we need a small axle, okay, and it's 1, 2, 3, 5 in the middle. Okay, there we go. And next we need a small gear and this element, okay? Okay, this goes right here to the very end of the axle, or rather to the base plate, and this part goes on top. Okay, before we get there, let me show you how it looks like. Okay, this is my construction right now. There you go. I need to hold this part, okay? Okay, now let's return to the instructions. Next, we need to prepare the motor. Mine is right here, okay? And first things first, we need this very, very small axle pin, and it goes right here. And the sort of back of the motor, okay, like so. Next, we need to find 4 pins. There we go. Now, if you're not sure, it's always a good idea to rotate your elements exactly as you see them in the instructions, okay? Because then you can be sure that all the parts are going in the right, are in the right place. Okay. This is our motor before and after. And next, of course, we need to place it on the plate. Okay, this is how it should look like. Let me show you from this point of view. Okay. All right, it needs to go right here. Now I need to count the pins. Okay, there we go. You see the two gears, the teeth of those gears must be meshed together. Okay, yeah. Now they don't want to move, and that's a good sign. Okay. What I still need to do is to kind of try and make those cables kind of, well, shorter, I would say. Okay, so maybe I'll try it this way. Because mine seems to be slightly longer. 1 and 2. Okay. For now, it looks okay. Now we need to find 4 connectors. 3, 4. And connect them together. Okay. Next, okay, this is a plate like this one. Okay, there we go. And now this part needs to be added to the base plate. So let's switch the view. Okay. It should go. Okay, 1, 2. It should go right here. I think. Yep. Let me check the instruction. 6. 1, 2, 3, 4, 5, 6. Now this part is kind of tricky. You need to apply some force, but not too much, otherwise you might accidentally break those connectors. Yeah, there we go. Okay. And I'm sorry, it's in the wrong place. It should be 1 bit to this side. Okay, let me quickly correct this mistake. Okay, fortunately, as you can see, it's quite easy to fix. Okay. It's a good practice to fix those simple mistakes as soon as you can spot them, because as you progress, it might be harder and harder to do. Okay. Now it looks exactly as it does in the instructions. Okay, that's good. Okay, now we're back with the instructions. Okay, this is the before and after. Okay, and now we need to find 4 pins. Now this part is pretty straightforward, and I'm not gonna switch the view yet. Okay, like so. Next, those square connectors, which are right here. Before and after. Okay, next. More connectors like these. Let me show you how it looks like from this view. Okay. Now this is kind of tricky because those parts should go right here. Okay. 1 and the other one. Okay. There you go. Finally, now's the time to connect the hub. Nothing works without it. Easily the most important part in any robot. Okay, as you can see here, in the before and after, we need to connect it to the connectors, but also to the cables of other sensors. Let me show you how to do this. Okay, first things first, try to connect the cables first. Okay, the motor needs to be connected to the B port, and the sensor needs to be connected to the F port, like so. Next, we need to make sure that the hub is connected. Okay, and here again you need to apply some force. Okay, you need to feel this out a bit. And you know, I wish I could give you some amazing tip on how to easily connect these parts, but to be honest, I almost always struggle with them just a little bit. Okay, so the best advice I can give you is patience, my friends, patience. Okay, try to make some adjustments to the layout of your cables as needed. Okay, and like this should be okay. All right, now we need to find 3 pins and place them exactly as shown here. Next, okay, we need the other base plate right here. And just place it on top exactly as it is shown. Okay, I'll do it like this. And notice that we need to connect it to these pins, but also to the connectors. Okay. As you can see here, my advice about patience is once again valid. Okay, give yourself time, don't be hasty. Okay, it's better to take 1 or 2 minutes longer when building this than to, you know, by accident damage the parts. And there we go. Okay. Here's how it looks like. Okay, Next, we need to find an axle that is 4 studs long. Not too long. Oh yeah, like this one. Okay. And we need to place it in the middle. Yeah, exactly here. And the next, is it the next one? No. Next, okay, we need to find this gear. As well as 4 longer half pins. 1, 2, 3, 4. There we go. And place them like this. Okay, so I have the gear and those pins. And let's place them, let's put them inside. There we go. Now we need another gear. I like this one. Okay, I have it right here. And also 4 very long axles. That's the before and after. 1, 2, 3. There we go. 4 axles. Okay, there we go. Okay, next. And these parts are, I think, right here. Once again, we need to find 4 so that they go on top of the axles. And notice that they are in a very specific position, okay? Try to join them exactly as you see in the instructions, or at least as close as you can, you know, and later on you can adjust it. Okay, and now we need to place this element on the base, like so. So we have this one, right? And we just need to slide it onto the axle, which is right here. Oops, there we go. Okay, this is how it looks like. Okay, now is the time to assemble the wooden parts, which are gonna make the top of our carousel, okay? First things first, we're gonna need those 2 elements, okay? They are going to create the column for our carousel. This is something that we want to achieve, okay? Let's move this away. Okay, for now, let's focus on these, okay? We just need to slide them like so until they are almost on the same level, okay? Next, we need to place this element on the very top. And now is the time to connect the arms. Okay, let me show you how I connect them in the top view. There we go. Okay, in those wooden parts you have those little sticking out parts, okay, and you need to just place them right here, all 6 of them. because we're working with wooden parts here, the elements might have very, very tiny differences, okay? So some parts will be easier to connect, others you will have to apply a bit more strength, a bit more pressure, okay? But still try to be gentle. Okay, there we go. And now is the time, of course, to connect this column, this superstructure, on top of this base made out of bricks, okay? Basically, all we need to do is just slide it down, okay? Kind of between those axles. Okay, there we go. The final touch that this carousel needs are, of course, little airplanes that are going to hang from the top. So first I'm going to show you the instructions on how to assemble one airplane, and then I'm going to do it myself and you'll see the other view, okay? So very first thing, we need two parts, wing and the fuselage, and you need to connect them together. You can see that there is this little slot left over, right? That's for the arm, okay? So next it goes in, and you can see that there's still some space, kind of a slot in the fuselage. That's for the pin, okay? That's where the pin comes in to block the entire construction and make sure nothing falls out, okay? Now I'm going to show you this from the top view camera. Okay, I'm going to first move the carousel and take all of the parts right here. Okay, so first things first, wings and the fuselage, okay? We need to take this, slide one into the other. Like so. Oh yeah. And you can see, I hope you can see. Camera, please focus. Maybe I will move this part, okay? Okay, there you go. This is how it looks like. There is still some slot left. That's for the arm, okay? Now I need to slide it right here. Until there is this tiny little hole left. And now's the time to insert the pin. Okay. It doesn't have to go all the way in. That should be enough. Okay. And as you can see, I have already assembled some of those airplanes early on. Okay, so all of these are now ready and waiting. Okay. So now all that's left to do for me is to hang those on the carousel. This is how they should be hanging. Okay, let's move it exactly as it is in the instruction. I'll take one of those and just hang it here. Now these are also need to be, there we go. Okay, you can see that they are kind of moving around, but they should not fall out. Okay, Now, if you haven't, unlike me, assembled all of the other airplanes beforehand, now's the time for you to do that. So pause this video if you need to and review the instructions, okay? If you have them ready by some accident, then all that's left to do is hang them on the carousel. And I will do that right now. Mm-hmm. You may need to wiggle them a bit, then it's easier for them to go down, okay? There we go. Yep. Okay, this is how they kind of should behave, okay? You can see that they are moving on this carousel, on this construction. They should have this very limited but still freedom of movement. Otherwise, we won't be able to observe how they move when the motor activates. That's the end of the building process, which means that the construction is complete. Complete, but not moving. So let's fix that and move on to programming. Here's how the carousel will work once you complete the program. By bringing a hand close to the distance sensor, you activate the motor, which activates the gear train, which propels the wooden superstructure, that is the carousel with little airplanes. Now, besides the motor, this model features a distance sensor and a spike hub. The hub powers and controls the other electronic components according to the program. Sensor will be used to control the program and, by extension, the entire carousel. The motor will propel the central column, causing it to rotate. And as the motor speed increases, the little airplanes mounted on the arms will move higher and higher up. That's the effect of the centrifugal force. Time to create the program. I will follow the step-by-step instructions provided on the platform, but you will mostly see me programming in the app. Don't worry though, I'll explain everything and will return to the instructions every now and then. So open the Spike Programming app and select your set. Today we are using Spike Prime. Okay. Next up, open a new project in Word Blocks. Okay. And the very first thing we need to do is to make the motor move once the program starts running. Okay. Or rather, the very first thing I need to do is to make this slightly larger so you can see everything well. Okay. So the motor must move with the right speed and in the right direction. For that, I need 3 blocks. When program starts, which is already here, this is the block that triggers the program. I also need to set speed to 50%. And, of course, I need to start the motor in the right direction, which is counterclockwise in this case. Now, this very simple program can already be tested and you should not skip this, okay? Testing the program early on allows you to detect any mistakes, be it in the construction or simple programs in the program, simple errors in the program, like the wrong motor port. Speaking of which, let's check if I have the right port selected. Let's go back to the instructions, okay? And you can already see that I have selected the wrong one, okay? So I need to correct that. Not A, but B. Okay. Now, once we've checked that, the hub in your robot must be connected to the Spike app. Now you can check this in the upper left corner right here. Okay, to connect wirelessly via Bluetooth, simply follow the instructions on the screen, and that's exactly what I'm going to do. The very first thing I need to do though is to activate the hub. Okay, mine is already updated. There we go. It's already connected, so let's test this program. When you're ready, run the program by clicking the play button in the bottom right corner of the interface. The carousel, right here, should begin to rotate. Okay. Stop the program by clicking the stop button. Okay, let's do that again. Notice that the model starts and stops very abruptly. In the next steps, we will improve this by adding a gradual acceleration and deceleration effect. Now, to create this effect, we will use a variable. Okay, first things first, we need to go to the variables category, create a new one, and let's name it speed. Okay, now from the variables category, we need to select set speed to block and add it at the beginning of the script, right after the starting block. Now, the initial speed should be 0, then gradually increase or decrease. Now, to make the variable affect the motor's operation, we also need to modify the motor speed block. Okay, so drag the speed block, which stores the current value of the variable, from the variables category to the input field of the set speed to motor block. Let's now move on to controlling the motor speed. For this, we will use the distance sensor. When it detects a hand or another object, the speed will start to gradually increase. Removing the hand will gradually decrease the motor speed. Now, to check whether something is in front of the sensor, let's use a conditional statement. If, then else. Now, place it before the motor blocks. Okay, like so. Okay, now for the condition, we must look in the sensors category and find is closer than block. There we go. Look at the shape of this block. This clearly suggests that it should be placed inside a condition field. Okay, is closer than 15 centimeters should be enough. Okay, it should be enough here. And the next, we must define what is to happen when the condition is met or not. If your hand is close to the sensor, the speed should increase by 5, a small but noticeable change. Now, if there's nothing in front of the sensor, the speed should drop down. So let's duplicate the block and change the parameter to -5, or rather -5. Okay. Now, to make the program work continuously, we need a loop, preferably one that keeps repeating forever. It must be wrapped around almost all the blocks except the one that resets the variable. There we go. So place it right here. Check if everything is inside the loop except the first 2 blocks. Okay? All right. Another thing we need to keep in mind is that the change in speed should be smooth, gradual, not abrupt. So by the end of the loop, let's add a small, tiny pause. You can find it in the control category. Wait. Not 1 second, that's a bit too much, but rather 0.1 seconds. Okay. Now, let's test this version of the program. Okay, let's run the program. Okay, at some point you may notice that the control does not work properly. Now for a cause, let's look at the variable, its value. Let's open the variable value monitor in the app. Here's the cause. The value of the variable changes without any restrictions. Okay? But the motor blocks only take values from 0 to 100. Well, they also take negative values, but that causes the motor to spin in the opposite direction, and we want to avoid that today. So the next step is to limit the value of the speed variable. We'll use a combination of condition blocks and operators. Okay, in the first gap of the main condition, I'll put the if-then condition. Okay, and in its input field, an operator. Okay, a less than operator to establish the first limit. Speed must be less than 100. Okay. The other limit will be similar. First, the if-then in the other gap. Then the greater than operator. And this time, of course, to establish the other limit, speed must be greater than 0. Okay, now from now on, let me show you the full program. Okay, from now on, the value of the variable will increase only if it's less than 100 and decrease only if it's greater than 0. So this should eliminate the control issue from earlier. Let's check it out. Let's run the program. Okay, nothing happens yet, but when I take my hand closer, okay, and you remember if my hand was away for a moment, it would start spinning in the other direction, but nothing happens now. And I can see on my screen that the value of the variable only goes from 0 to 100 and nothing else. Nothing beyond that, rather. Okay. I'm going to include one more feature in this program, okay? A lively melody that plays along as the carousel spins. A playback, if you will. It will be in a separate stack or script, and it will play whenever the program starts. So let's add another when program starts block, here for example. Next, to add the melody, I must go to the sound tab, then to the sound library, okay? One way to go there is, for example, to add sound, okay? And once you're in the library, look for medieval music. Select it, okay? It's selected, and now close the library. Okay, then let's take play sound until done under the second script. Don't forget to select the right sound. Okay, and of course this sound should play as long as the program is running, so we need another forever loop. There we go. Now the program is complete, and it was the final step in the instructions. Okay, as you can see, this is the end, so let's test the final version of the program for the carousel. Now is the time for the final test. Okay, I hope you can see and hear that everything works exactly as we planned. Now, if your program and robot are identical to mine and somehow something doesn't seem to work with the program, try restarting the app. Oftentimes it resolves all of the problems. Okay. With the building and programming stages complete, now comes the time for experimentation, or playing with the robot. Now's the time to freely adjust and modify the creation, perhaps according to a goal set by you for the entire group, different goals picked by students individually, or no defined goal other than pure creativity. Now there's plenty of ways you can modify this robot. You can paint the wooden parts, design and cut your own to exchange the little airplanes. You can modify the program, adjust the control system, change the melody, or even record and upload your own. Whichever idea you choose, I hope you will enjoy the entire lesson. Because according to both teachers and students, that's key in robotics, learning while having fun. This was the Carousel lesson for LEGO Spike Prime and X-Tool. My name is Dominika from RoboCamp. Thank you for spending your time with me today, and see you next time.